Okay, I'm going to start going over the 2018 geometry exam that was given in January, which was just a couple weeks ago, well, a couple months ago at this point. My plan is to go over on each video 5 multiple choice problems, and then once we get to part 2, which are the short answer questions, it depends on how long the question's going to take, so we'll see once we get there. All right, but on this video I'm going to go over problems 1 through 5 from the exam. If you're doing this to get extra credit, you're going to need to write down all the notes that I have, because when I check it, I'm going to check to make sure that you have down all the notes that I've written for you to help you out. All right? So let's get to it. Let's get to problem number 1. All right? Oh, and also, each one of these problems is worth 2 points on the exam. You don't get any partial credit, so they're not going to look at your work. You do want to be very careful, because many times with these problems, they're going to give you answers that will be right if you go in a wrong direction. So you really want to be careful, really read the question, look for the key words, key vocabulary, all right? So it says here, in the diagram below, a sequence of rigid motions maps ABCD onto JKLM. And this is down here, if the measure of angle A is 82 degrees, the measure of angle B is 104, and the measure of angle L is 121. What is the measure of angle M? All right, so first of all, make sure that you write down these notes. Okay, we've talked about 3 rigid motion transformations. One of them, the first one I believe we talked about, well, I think we talked about rotations first, but either way, the 3 that we talked about were reflections, rotations, and translations. All right? When you do a reflection, a translation, or a rotation, all the corresponding parts are preserved or maintained. So, in other words, all of the sides, all of the angles on your new shape are going to be exactly the same as your original shape. Now here, you cannot, if you're having trouble looking at the picture and you're not really sure as you see it going, we don't know which transformation it is, or that really doesn't matter. But if you look here, if we label this one, well, let me erase that. Okay, you can look at the letters. I always tell my students to look at the letters. So A is going to correspond to J. So that means whatever angle A is, J is going to be exactly the same. All right? And then B is going to correspond to K. So whatever angle B is, right, whatever angle B is, then K is going to be the same. Okay? And then whatever angle C is, then angle L is going to be the same. So I'm just going to do it color coded, so I won't do all the different arcs. And whatever angle D is, angle M is going to be the same. All right? D and M. Okay? So we have that, and we have that. Okay, so now they give you some information about the angles. All right? So now they actually tell you what some of the angle measures are. And then we have to figure out angle M. So they tell us that angle A is 82 degrees. So this is, now I'm going to erase these now. And A is 82 degrees. So I know A is 82. Well, if A is 82, that means J is 82. So I can put that here. All right? Then it says that angle B is 104. So this one's 104, and if angle B is 104, that means angle K is 104. So I can put that here, all right? And then I know that angle L is 121. Well, if angle L is 121, then angle C is also 121. All right. Now they're asking for angle M. Well, that's going to be this last angle. We have a four-sided figure here. All right, four-sided figure. And here's another note I want you to write. The interior angles of a four-sided figure add up to 360 degrees. So I want you to write that down. So I know all four of those angles add up to 360 degrees. So now what I could do is I could just add up the three that I have. So I have at this point 104, 121, and 82. So I can quickly add those up. 4 plus 1 plus 2, 7, and 2 plus 8 is 10. So I have 307 degrees. So that means the three angles in this quadrilateral, this four-sided figure, which is called a quadrilateral, by the way. It's a four-sided figure. The three angles that I have on the inside are 307 degrees. So now I just do 360 minus 307, and you end up with 53 degrees. So that's the measure of angle M, 53 degrees. All right? So go ahead and write anything down that you need to write down. Okay, let's move on to problem number 2. It says parallelogram. Okay, first off, once you hear or see, I'm always telling students, look for the key words. Parallelogram, very key word, right? Very key. I mean, if you don't know what a parallelogram is, you're going to have a hard time on this test. Okay, so make sure when you see these words, start thinking about what do they mean. All right, what does that tell me? Remember, parallelogram, once you see that, well, let me read the rest of it. It says parallelogram HAND is drawn below with diagonals. That's another very important thing to think about. Diagonals HN, so HN would be this diagonal here, HN, and AD would be this diagonal here. All right, intersecting at S. And then it says which statement is always true. So let's talk about what we know about a shape if we know it's a parallelogram. Right? If we know it's a parallelogram. So these are some notes I want you to write down that I thought might be important. And a couple other things. If you know it's a parallelogram, first of all, parallel, you know the word parallel right there. So remember, your opposite sides are parallel. Now, I don't really know if that's going to be important for this. I really don't. But that's something you should know and think about whenever you're doing these problems. All right? The opposite sides have to be parallel if it is a parallelogram. The opposite sides have to be congruent. That's another thing. All right? And there are some other things about a parallelogram. The consecutive angles are supplementary. I don't know if that's going to be important here, but it might be in other problems. Then these that I have for you to write down, these notes, okay, these are a couple other things. The diagonals of a parallelogram always bisect each other, which means to cut in half. That means that when we see these diagonals HN and AD, they bisect each other, okay? It doesn't mean that they're the same length, but they bisect each other. So what I could do is say, all right, if HN bisects AD, then that means that this right here, I don't want to just put 2 marks. I've already used 2 marks, so I'm going to do 3. These have to be the same. And then also HS, which is this one, and SN have to be the same. Okay? Those have to be the same. Now, SN is not necessarily going to be the same length as AS. Okay? But we do know that they bisect each other. All right? And also the opposite angles of a parallelogram are congruent. That might be important. there are a lot of things. Once you look at the answers, we'll see which ones to focus in on. It says, which statement is always true? All right, so is HN equal to 1/2 of AD? So what they're saying on this first one right here is HN, remember HN is going to be this side here, the entire diagonal, is that the same as 1/2 the length of AD? Well, I don't see any reason why that would always be true. It might be true one time, but definitely not going to be true all the time. So it's not always true. All right, what about the next one? Is AS, so AS, remember that's this one. That's this side right here, AS. Is that the same length, is that 1/2 of AD? Well, it looks like that's definitely going to be true because AS, remember bisect means cut in half. Bisect means to cut in half. So that means AS from A to S is going to be 1/2 of A to D, right? So that looks like that's going to be my answer there, okay? That's going to be my answer there. And yeah, so that's my answer, all right? So, all right, looking at problem number 3, it says the graph below shows two congruent triangles, ABC and A prime, B prime, C prime. It says which rigid motion would map triangle ABC, so that's this one I'm outlining red, ABC, onto A prime, B prime, C prime. Now, as I look at these answers, I notice 2 of them have an option of rotations, okay? And then one of them translation and reflection. I want you to write down these notes right here. When you do a rotation on a coordinate grid, for every 90 degrees, a point will move 1 quadrant over, okay? So write that down, okay? But listen to what I'm saying here. If you have, remember your quadrants are 1, 2, 3, and then 4, right? Those are your quadrants. So right now, point A is in quadrant 1. If it were to be rotated 90 degrees either way, it wouldn't matter clockwise or counterclockwise. If it were to be rotated 90 degrees, it would either end up in the second quadrant, so it would end up somewhere over here, or if it was this way, it'd end up somewhere over here. Either way, if you notice, our A prime is still in the first quadrant. So there's no way that this shape, ABC, was rotated 90 degrees counterclockwise. Okay? If it had been rotated 90 degrees counterclockwise, it would have ended up in the second quadrant over here. Right? Somewhere over there. Even if you don't know exactly where it would end up, you should just try and remember 90 degrees means 1 quadrant over. Okay? 180 degrees means 2 quadrants over. So we can eliminate 1, and then if you look at 2, 180 degrees, well, that would be 2 quadrants over. So 2 quadrants over would mean it would end up somewhere in the third quadrant. Actually, it doesn't even matter if you do counterclockwise or clockwise. It would end up in that quadrant, the third quadrant. Right? It would not end up where it did, A prime, which is still in the first quadrant. Okay? So now it's just between, so we can eliminate 3. Now it's just between 2 and 3. All right? If I look at 2, a translation of 3 units to the left and 3 units up. Well, that would have to be true for all the points. And the thing is if you just look at A, you could take A and move it 1, 2, 3 units to the left, 3 units up, and you'd be like, oh, wow, that works. The problem is it doesn't work for my other points. If I take C and I move that 1, 2, 3, 1, 2, 3, that's not where the point is. The translation's got to work for all of them. So we can go ahead and eliminate that. Now remember, we know our answer is 4, but let's just recall the line y equals x, what that looks like. Y equals x is the diagonal line that goes right through, it's basically, or it is, up 1 over 1. Up 1 over 1, up 1 over 1. That's the line y equals x, right there. So that does make sense because if I take A and count up and over, up 3 over 3, if I take B and I count from this point B and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? It all works. That's the rigid motion that was done. A reflection over the line, y equals x. All right, let's look at problem number 4. It says a man was parasailing above a lake at an angle of elevation of 32 degrees. They marked that for you, that's nice. From a boat, as modeled in the diagram below. You should also notice that we have a right angle, so that's our right triangle. You're either going to be, you should be maybe thinking Pythagorean theorem or trigonometry, depending on when you're watching this video. If you're in my class, depending on when you're watching this video, we might have not gotten to trigonometry yet. If you're watching this to review, it's something you should be familiar with, okay? It says, if 129.5 meters of cable connected to the boat, connected the boat to the parasail, so that's obviously this line right here, approximately how many meters above the lake was the man? Okay, so now, first of all, what are we actually looking for? Okay, we've got this triangle here. What are we actually looking for? Are we looking for 1, 2, or 3? Which one of these sides are we looking for? Well, obviously we're not looking for this side because we already have that side, all right? And you have to be able to determine, because they could ask this question in a way to where you could be looking for 1 or 3. But when it says approximately how many meters above, that's the key word, above, all right, that means that we're definitely looking for that side right there, okay? We're looking for that side right there. So you could label that X, you could label whatever you want, but that's the side we're looking for, all right? Now, if you, I'll move these notes up now. Anytime, this is something you need to write down. Anytime that you are given one of the acute angles of a right triangle, so acute means less than 90, this 32-degree angle right here, that is an acute angle. And are looking for a side or an angle. And in this case, we're looking for a side. You're going to be using trigonometry. Now, a lot of students, they like using Pythagorean theorem, a squared plus b squared equals c squared. The problem is, and hopefully you're thinking about this as you're looking at this, and what is the problem? Why can't you use Pythagorean theorem? A squared plus b squared equals c squared. Well, you can't because you need two sides. We don't have two sides, all right? So we cannot use that. We're going to have to use a different strategy. And so we're going to be using trigonometry. And if you've taken trigonometry before, you're very familiar with this SOHCAHTOA, all right? But I want you to write it down now. We'll be in my class presently, 2018. We're going to be doing this week, but depending on, so hopefully we'll get to it before you watch this. If not, you'll be introduced to it. But SOHCAHTOA, write that down. Okay, and what it stands for, at this point, you have 3 sides. Every triangle has 3 sides. Based on the angle, this is my opposite side. The 129.5, that's across from my right angle, so that's my hypotenuse. And my side down here is my adjacent side. That's what that's called, the adjacent side. Now, we're actually looking for the opposite side. That's the one we're looking for. We're looking for the opposite side, and we have the hypotenuse. So since we're looking for the opposite side and we have the hypotenuse, we're going to use this SOH part. And the S stands for sine. What it is sine of the angle, so 32, that's our acute angle, is equal to the opposite side, well, we'll call that x, we don't know it, over the hypotenuse, which is 129.5, okay? Now, what you're going to do, and there are a lot of ways, other ways to do this, what I'm going to have you do is just go in your calculator and put in the sine of 32. So now, once you're doing that, One thing you want to make sure in your calculator, whatever type of calculator you're using, you could use your phone. If you turn it sideways, it has the trig functions on it. Make sure in your mode that you're on degrees. So if you're using one of these calculators in class, or you have your own graphing calculator, if you notice right now it's in radians, you need to change it to degrees. Very important. There's nothing on your exam where you're going to need radians. It has to be in degrees, okay? So I'm going to hit enter there. I'm going to go back, and I'm going to do sine of 32. All right, sine of 32. Okay, so I get this decimal. I want to write that to 4 places. All right, 4 places. So I'm going to put that over here, and I'm going to replace that sine of 32 with 0.5299. So I'm going to replace that with 0.5299 is equal to x over 129.5. All right, and then I'm just simply going to cross multiply. So I'm going to just put this over 1, and I'm just going to cross multiply. So we all love cross multiplying. So I'm going to take this, multiply this, and x times 1, that's pretty easy. What you end up with is x is equal to, and I'm going to go back in the calculator. I already have my number up, so all I'm doing is multiplying that by 129. Actually, I'll actually write it down. I'm actually going to write down, all right, so x is equal to 0.5299 times 129.5, right? So just multiplying them by each other, okay? And then once you do it, you get x is equal to, and in the calculator, so I'm just going to do times 129.5, all right? And you end up with 68.6. There we go, 68.6 feet. And that is our answer. All right, here's the last one for this video. Number 5, it says a right hexagonal prism is shown below. A two-dimensional cross-section that is perpendicular. Perpendicular, very key word here, perpendicular to the base is taken from the prism. All right, so a cross-section. Okay, which figure, now the question is, which figure describes the two-dimensional cross-section? And then we have some options here. And we'll look at those in just a second. What I want to do now is actually have you write down notes. What is a cross-section? All right? So write those down. A cross-section is the shape we get when cutting straight through an object. The cross-section of this object, let's not write this part down. And that's actually not going to be true for what we're doing. All right? It is like a view inside into the inside of something made by cutting through it. Okay? Now let me look at, let's just look at some cross sections here. Examples. All right? Okay, so we have this. Now, there are 2 different ways. So I have this picture here. 2 different ways you can have cross sections. All right? It can be parallel. Now look at this. Look at this shape that focus in on what I just circled right here. Okay? You have the same shape. All right? You have a cylinder. You have a cylinder on the left. You have a cylinder on the right. One of them is having a parallel cross section cut out. Do you notice how it ends up being a circle? Now on this other one that is perpendicular, which is straight up and down, you actually have a cylinder, but the cross section is actually a rectangle. So you have to be careful, all right? It's a big difference when you take the cross section that is parallel versus perpendicular, okay? So now, which figure describes the perpendicular cross section, two-dimensional perpendicular cross section, all right? Now, if you look, perpendicular would be up and down. So first of all, I don't see any triangles here, but let's take a look at what perpendicular would mean. Okay, perpendicular would be straight up and down. So I'd be cutting like this, right? Then I would be cutting over that way, then over straight this way, and then straight down. Right? We're going to be talking about this more in class. I wish I could turn this figure towards us so we would see that this is a rectangle, because it is definitely a rectangle. Okay? If you can imagine me twisting this thing, rotating it, you can see it's a rectangle. We're going to talk more about this in class. If you've already done things like this, then you've seen how the different shapes, how the cross sections look. If it were parallel, then it would just definitely be a hexagon. But it's not parallel, it's perpendicular, which means you're going to end up with a cross section that looks like a rectangle. Okay? All right, so that's it. Make sure you wrote down all those notes. And I suggest that when you watch these, make sure that you've tried the problem before you actually watch these videos. Okay, try the problem so that you can see if you're right, if you're wrong, and what mistakes you may have made. Okay?